Let's talk progress on our variometer and what happens when theory meets reality. Um, I've got this far, and you can see, I put this shaft through there. And as I'm going along, I run into some issues. One of them is that when I was winding the coil, this collar wasn't big enough, and the wire kept jumping over the end. So, okay, you say, well, that's no big deal. You just make the collar a little wider. Yeah, and that's true, but you also have to remember that you got to keep clearance between the outer shell and the inner ball. Okay, so I did that. Then, as I started progressing along a little farther with other aspects, so I get the coil wound and I get these two centerpieces soldered down in there, like I did in the last video. Yeah, okay, so now it's time to attach these upper wires to the outer coils. And as I said before, it has to act as one big coil. So it starts here, runs down, connects here, goes through this coil, comes out here, goes down the bottom coil. And so that started becoming an issue. It's like, okay, I've got this rod in here, but I would have to cut the rod because this is metal. I have to cut the rod and then put in an insulator in here, and that's starting to become kind of a headache. The other problem is that the only place where this rod is attaching is this little thin spot right here and here. And all you have to do is get a little leverage on here and torque this, and that shaft will spin. And it doesn't matter how much glue you put on there, sooner or later it's going to pop loose, especially if somebody comes along and they have their finger here and then does that. There's just no way to stop it. The amount of leverage would just be crushing. So let me show you what I have been up to, some steps I have taken. Okay, so let's do that. Let's go through the, 1, 2, 3, 4, 5 more steps that I went through to get where I am right now, and I'm reprinting these to the newest standard. To summarize the problems with this model, first we have a solid rod through there, and we need to isolate it. We need to cut it electrically, and in doing so, that will weaken the shaft. So we need to somehow do that without weakening it. The other problem is that there's just not much of a contact point here to mount the rod to, and it's easy to torque it out of position. So, okay, let's bring in the big model, and I can show you what's been going on. As you can see, I've added a tube through here, and one half of it looks like this. And you can see it has a tube shaft so that I can take my mounting shaft and I can place it in here. And yeah, so I get more contact area to glue the shaft to, and that means there's going to be very little chance for it to torque out of position. And I can put in two pieces. I don't have two pieces of the same size right now. I've ordered some, but I can put in two pieces like this, and they're electrically isolated. Now, the next problem becomes, how do I run the wires to here? And yeah, okay, so that can be an issue. And what I did was I simply drilled a hole through here so that I can put my shaft in here. I can bring my wire up through here and solder it anywhere along this tube, and repeat the same thing on this side. And then when I glue these together, I have a ferocious contact point. This is not going to be able to torque, and I have a lot of support out here so that the shaft will not wiggle even though it's split into two. Okay, so you may say, well, that's a pretty fine solution right there. However, let me take you to my last solution, which I'm printing up a big model right now. And that is, I think it's going to be the one that I run with. Here you can see some of the changes. I've still got this rounded support across this way, but now there's 2 holes in it. And I've also added some support the other way. Let's look underneath here. This is probably the smallest change, but I was concerned that this plastic would sag over time, so I just added a little bit of support there. And the most important thing is this shaft. I've maintained the shaft, I've thickened it, and I have added a barrier right here between the 2 sides. It's just about 1 millimeter, so that I can put a shaft here like that and a shaft here like that and not have to worry about them shorting, getting pushed together or something, or the wires coming in contact. And then here you can see the hole, and what happens is the wire will come from the upper part, so it's the upper part of the ball right here, and that wire will run down to the center here, come through this hole, and attach to this rod. Now in the smaller one, it would be nice if I could use a solid rod, and I can. What I can do is I can either slot this or drill it and run the wire into it, solder it, and then push any extra wire back out of the hole. And I will have a really good joint there and a very solid shaft right there. And of course, then I do the same thing on the other side. And then when I put the top on, the shaft being in position already will help align these pieces, and it will go together much better. So most of these changes are in the process, help in the process of putting this thing together. Yeah, you know, before this thing will work, but it takes a lot more effort to try to produce this shaft, and you know, you have to do all this fiddling around on the inside. This shaft will make it much easier, and there won't be as much, you know, ad hoc work going on. Okay, well, that was it for these improvements. I hope you found that useful and interesting in your DIY crystal radio and variometer experimentations.